With my sensors configured now, it's time to enable our communications. I'm going to add in a GOES radio. The first options here are what radio type and the DCP address. So the DCP address or ID is that assigned by NESDIS or by NOAA. I come into my self-time channel options. These are mainly the options and settings that you'll be assigned by NOAA or NESDIS again. Your channel number, your transmit interval, your window, your baud rate, your assigned time are all assigned by NESDIS. Should be a straightforward correlation of bringing them from your assignment over to the interface. Your time order or your data order here is newest data first. Append battery, this is important to use this option instead of trying to add it in as one of your data values. Your appended battery will be a loaded battery voltage, so you'll get a better representation of the health of your battery. To decode this, you can see the equation right here for decoding it. It is in 0.1 volt resolution, so you get good resolution on your battery voltage. Pseudo binary for your data type or data format. And you also have a space delimited for chef or for ASCII data. Channel order or scan order. So channel order would be all of the values from a single sensor grouped together. So if I was doing stage and rain, I would get my stage values, and then I'd get my rain values with the newest stage to the oldest stage, newest rain to oldest rain. If I did the scan order, I would get the newest stage, newest rain. Then I'd get the next newest stage, newest rain. Next newest stage, newest rain, all the way up to the oldest stage, oldest rain. So those are time series data. These are channel order data. At that point, you've set up the radio for transmitting, but you have not decided what you're going to transmit yet. So this is where we add the data that we want to transmit. We have it set up for doing water level. We want that. We want the 15-minute stage value. Number of values is set to 4 by default. This is based on a 1-hour transmission and 15-minute measurement rate. So that would be our 4 new values. If we were to do redundant data, we would set this to 8 for one set of redundant data. If we wanted 2 sets of redundant data, we would set it to 12. I'm going to set it for 1 set of redundant data. The precision is the number of digits to the right of the decimal that should be preserved and transmitted. And the width is how big the field is of the value. So in binary, 3 characters is a very common value for this option. That will give us a value in binary with 2 digits to the right and a width of 3 characters. That'll give us a range of 1300 plus or minus. If you're to use a chef format or a space delimited format, ASCII format, then you would want to change this here to probably to a 5 or to a 6. A 5 will give us a range of plus or minus 99.99, so 5 characters. If I needed to go higher than 99.99, I would change it to 6. I'm going to stay with pseudo-binary with 3 bytes. Shrink that down. I'm going to come back in and add in my rain gauge. Again, I want redundant data. 2 digits to the right, 3 binary bytes, every value. This every value option here is used if I need to log data at a faster rate than what I want to transmit it. So for example, if I had my measurement rate set to 5 minutes, if that was set to 5 minutes, but I still wanted 15-minute data on my transmission, I would have this set to every 3rd value. I'm going to leave it at every value. So now I have it set up to transmit my stage and my rain with one set of redundant data, and my battery voltage will be appended. The other option is to not append it. So I want that appended. So at this point, my GOES radio is configured for self-time data. At this point here, I could save that configuration file to the hard drive, ready to be retrieved later anytime I'd like. I can also apply it to the data logger at this point. So I'm going to go ahead and apply it. Now, the first time you apply a configuration to the data logger, it can take several minutes to do so. It not only generates a CR basic program and loads it onto the data logger, but it also takes this complete interface that we've been working with and loads that onto the data logger. That interface resides on the data logger, so that if you have a data logger that has the ability to speak Wi-Fi to a wireless connection, that you can activate this same interface hosted by the data logger. This interface will show up on a smartphone when you're using it with the Wi-Fi interface. Click OK. Now that configuration has been applied to the data logger.